Hello, welcome to Physics World. This is Mrs. Homberg, and in continuing our work with current electricity, we're going to understand how we will be able to understand and solve parallel circuit problems. Here we have a sample problem. We notice that there is a battery and there are three resistors. What we're going to do is name this R1, R2, and R3. As this video is going to show you, we're going to follow the same process to solve all of these simple circuits. Using our protocol for filling in with a highlighter or a colored pencil, we will go out of the high voltage end of the battery and highlight all wires that are connected to this high voltage, which tells you that this whole wire till this node and up to the resistor here, and up to that resistor, and up to that resistor are all at 10 volts. We should write that in, that this pink is at 10 volts, this is at 10 volts, and this is at 10 volts. We now continue coloring in, and we will see that we will put blue for our low potential end. That means all of these wires are at 0 volts. So what does this tell you? We have to use our typical procedure of getting total resistance and get the overall current in the circuit, the I battery, one of our first few steps. But what you realize is that we can tell right away that pink to blue is 10 volts, and there are 3 sets of pink to blue. And therefore, each one of those is at 10 volts. We'll come back to that. Let's get the overall resistance for this parallel circuit. Well, if we look at our rules for parallel circuits, we know that it is based on 1 over Req equals 1 over R1 plus 1 over R2 plus 1 over R3. So when we go to fill that in, we would see that 1 over RQ equals 1 over 15 ohms plus 1 over 10 ohms plus 1 over 6 ohms. Now putting this in the calculator can be a little tedious, but this is what I suggest. Put 15 to the minus 1 plus 10 to the minus 1 plus 6 to the minus 1. And you'll notice that whatever this answer comes out to be, if you then put that raised to the negative 1, you will get the overall resistance for the circuit, which in our case is going to be 3 ohms. So we can put that right here, 3 ohms. Well, how are we going to get the overall current? Well, we know that we are led by V equals IR, Ohm's law, and now we're going to do it for the overall circuit. So we know the overall voltage, maximum. We know the Req, we just solved for that. So therefore, we can get I all by itself. I battery equals V of the battery over Req, which is going to be 10 volts divided by 3 ohms, and we will get 3.33 amperes. We're going to use that rounded to the 2 decimal places because otherwise it becomes rather unwieldy. So now, what's the second step? We have to find the voltage drop across each resistor. We have to find the current through each resistor. So all of this leads us to steps like, how do we know any voltages? How do we know any currents? Well, we do know that this 1I battery is going in here. So now, what can we do with that? We know that it splits up into this current, and this current. What goes in must come out. However, we don't know any of the other smaller currents. Let's see what we would do to figure them out. Well, as I mentioned earlier, this is pink, that's blue. That means that 10-volt drop applies to any place you see a pink and a blue. Pink and blue, 10 volts. Pink and blue, 10 volts. Pink and blue, 10 volts. So this is very different from series. In series, we could say that each of the elements in series had the same current. Now these elements in parallel have the same voltage. Now we can easily check out how to figure out the current through each little resistor. That's, again, an application of Ohm's law. V equals IR for each one of those. So if we're trying to get the current, we're going to put V over R for each one of these. And we're going to get 0.67 amperes, 1 ampere, and 1.67 amperes. How can you check your answers? Well, we know by Kirchhoff's circuit law that sum of current in equals the sum of current out. Well, if we look at this node up here, let's call it node A. At A, what's the only current going in? I battery. What is that going to equal? All the currents going out. I1 plus I2 plus I3. Check your answers. Do the three currents we have calculated add up to 3.33? They should.